Good morning, majors. This is Unit 4, Day 1 notes, and we're just going to learn how to graph these exponential and logarithmic functions. We're going to try 2 to the x. This is an exponential because the x is an exponent. So I already wrote this down. When x is 0, we have 2 to the 0, which is 1. When x is 1, we have 2 to the 1, which is 2. And then 2 squared, which is 4. And then 8. And then 16, 2 to the 5th power is 32, and you can see it grows very quickly. Even the small number 2, when it has an x as an exponent, it grows very quickly. Let's see what happens when we have a negative exponent. 2 to the negative 1, well, that just makes it 1 over 2. Do you see my number is not negative though? My number is just smaller. So 2 to the negative 2 is just 1 over 4. And then 1 over 2 to the 3rd power, which is 8. And then 1 over 16. When we graph this, if you're confused about how to graph this, always just make this chart, this table, and that'll help you graph it. At 0, when x is 0, my value is going to be 1. It's never going to go to 0. At 1, my value is 2. So small change. And then at 2, it's 4. And then at 3, it goes up to 8. And then at 4, we go up to 16. At 5, we go up to 32. And then at 6, we're already up here at 64. Do you see how quickly that grows? This one is even off the chart, so I'll say maybe like, I don't even like right here, okay? And does it ever go past this x-axis? Let's look. At -1, which will be right here, we're at 1/2, so it's tiny. At -2, we're at 1/4, but it's never going to go below 0 or even touch 0. It's just going to get infinitely close. So this is an exponential. This is y equals 2 to the x. The domain, even though sometimes it kind of gets hidden with this x-axis, it is going to keep going to the left. So it's going to be -infinity to infinity. These are my x values. There's no restriction of any x I cannot plug it in for this function. My range is never going to go or even touch 0. So we're going to go from 0, because it's positive, we're going to go up to infinity, but we can't ever actually touch 0, so there's no brackets there. There's no bracket. The horizontal asymptote, there is going to be a horizontal asymptote right here. This is when y equals 0. And the x-intercept is when x equals 0, which is 1. Our value is 1. So we write it as an ordered pair, 0, 1. It says exponential growth, 10 to the x, is faster growing than the polynomial x to the 10. So exponential always grows quicker. So the blue one is probably going to be the 10 to the x. And then the green one is x to the 10. Exponential growth, we know that that goes up. Exponential decay, from the left to the right, we're going down. We're decreasing. And this will look something like what we just did, y equals 2 to the x. An exponential decay, we're going to have a negative exponent. Y equals 2 to the negative x. What this really looks like is 1 over 2 to the x. Okay. Or we can pull this x out, and that can be 1 over 2 to the x. Okay, this is our generic or general function. Our y asymptote is going to be, or horizontal asymptote is going to be when y equals k. Go ahead and flip your paper over. Last class we learned how to manipulate this to solve for x, but this one's just saying look at the graph and solve for x. Where do we develop, where are we going to look when this graph is equal to 4? So we're going to go on the y-axis up to 4. I'm going to go over, and it looks like x is 2. Two to the x equals 8, you're going to go up. Where does it equal 8? You're going to go up to 8. And then you're going to go over. And that would be, I think we said on the last one, that one was 3. 2 to the third power is 8 when x equals 3. 2 to the x and 5. It says in words, what power of 2 is 5? In order to figure this out, we'd have to go up to 5 and then go down. It looks like it's about 2.3. We know this is going to be a decimal. You can check it in your calculators if you want. The inverse of an exponential function logarithm. So graphically reflects across the line y equals x because they are inverses of one another. Logs and exponentials are inverses of one another. So there's this line y equals x, and it is going to reflect across that line. The domain of a log, let me just kind of graph it. It's going to look something like that. The domain of a log, it's going to have a vertical asymptote at x equals 0. So we're going to start at 0 and we're going to go to the right because there's no negative in there. The range, it looks like it goes down infinitely, and we're going to go up slowly but infinitely. So this is going to be negative infinity to infinity. And there's a vertical asymptote at x equals 0, so I don't know what they want right here. X equals 0, and then vertical asymptote. I don't know. The x-intercept is going to be actually, if this point is 0, 1, then it should go through this point 1, 0. So let me just fix that. That is very important. Remember, when we do the inverse, we can also look at it, just switch the x and y's. So this is going to be 1, 0. All right, the exponential equation and then the logarithmic equation. In order to make it into an exponential, we take the little one to the answer, right? Little one to the answer, and then that equals the expression. That's how we go back and forth. We can go back and forth in between these. So keep this, you're going to need it. I will try a couple. This is log. This is log of 10 divided by 10, or the square root of 10, which is log 10 to the first power over 10 to the 1/2 power. Remember, if there's a fraction, we can subtract these to move it up. So 1 minus 1/2 is 1/2. So this is equal to log of 10 to the 1/2, or square root of 10. And since there's a log with base 10, since we don't have a base, we know that's base 10, these are going to cancel, and we're going to be left with this exponent right here, which is just 1/2. These need to be the same in order for these to cancel, so the 4 and the 2, but I can make this 4 the same. So this will be 2 squared, and then log base 2 of 3, and then this 2 will cancel with the log base 2. I need to rewrite it. I'm just going to move this in front. So this is going to be 2 log base 2 of 3 squared, all squared, because we can multiply it. And now these can cancel. But we're still going to get 3 squared. So this is equal to 3 squared, which is 9. Find x if log base 3 of x equals 5. Well, we can make this into an exponential. We're going to go back and forth. So we're going to take the base, which is 3, to the answer, and that's equal to the expression. So 3 to the 5th is equal to x. And we can, evaluate that. 3 to the 5th power is 243, I think. Try it. If it's already an exponential and you can't solve, we can't make this into 3, have a base of 3. So for this one, what I would do is just take the log base 3 of both sides so that this 3 would cancel. So we'll say the log base 3 of 3 to the x. If I do that to the left, I have to do that to the right. Log base 3 of 17. Okay. And then, as I said, remember this will cancel. We'll have x equals log base 3 of 17. And this is something you can plug into the calculator and evaluate. Okay, go ahead and flip your paper over. Alrighty, so my parent function is y equals 3 to the x. So remember what the 2 to the x looks like? It's going to increase quickly. So the transformation of y equals 3 to the negative x is actually 1 over 3 to the x. So this is going to decrease. And it's going to look something like this. I know at 0, anything to the 0 power is 1. So I know it's going to go through 0, 1. And I know at negative 1, we're at 3. When I plug in negative 1 right here, this flips and we're at 3. So it's going to look maybe at negative 2, that's 9. 3, 4, 5, 6, 7, 8, 9. So I know it's going to look something like this. And remember, it's not going to touch the x-axis. It's going to get infinitely close. It looks like it does, but it doesn't. It gets infinitely close. So the y-intercept is going to be at 0, 1. The asymptote, we still have this asymptote right here, y equals 0. The domain is going to be from negative infinity to positive infinity. So we're going all the way from the left to the right. We're going to go infinitely up and infinitely to the left. So this is going to be negative infinity to positive infinity. And the range, it starts almost at 0. It's going to get infinitely close to 0, and it's going to go up infinitely. So I'm going to say 0 to infinity. But remember, we can't include 0 and we can't include infinity. All right, let's look at how this graph differs from the parent function. Write down the parent function is y equals 5 to the x, right? So the plus 4 is going to go the opposite direction you would think. So instead of to the right 4, we're going to go to the left 4, right? Left there also. And then the minus 2, that's our y's. You know that is actually the proper direction, which would be down 2. That's it. So this is an exponential growth function, and we're going to shift it. It was going to hit the y-axis at 0, 1, but now we're going to move it to the left 4. So this was a point. We're going to move it to the left 4, and then we're going to move it down 2. This is a point now. And there was an asymptote right here at y equals 0, but now we're going to move it down 2. So this is our new asymptote, y equals negative 2. And I can write that in there. I know that 5 to the x, when I plugged in 1, 5 to the 1 power is 5. So when x is 1, my value is 5. One, 2, 3, 4, 5. But now I'm shifting everything to the left 4 and down 2. Okay. So I'm just going to draw it It might not be perfect. You can try another point if you would like. And it's going to go up infinitely and to the right infinitely, and this is going to get infinitely close to this axis right here. So my domain goes to the left and to the right, so it's negative infinity to infinity still. My range is going to start down here at -2 this time. It doesn't include -2, it's never going to touch that asymptote, but it goes up infinitely. That's a horrible infinity. The critical points. Well, I know that -1, 2, 3, 4, -1 is a critical point. It was where they touched the x-axis, the y-axis, but this is my critical point, -4, -1. And I tried, we also want where it's going to hit it was going to hit the x-axis, and now that point is going to be -3. There's another point I found, -3, 3. So -3, 3. Alrighty, guys. I want you guys to try this one. So when you do this, you can actually plot some points and make sure that it's reflecting across the line y equals x, and then see what happens when you have a -x in there. And then you can check it with your calculator. I decided I'm going to go over this, so I want you to pause the video and go ahead and fill in this chart real quick, and then come back and I'm going to have this chart filled in. Alrighty guys, welcome back. So I just plugged in 0 into the x and y. I know that y value is going to be 1. 1 is at 3, 2, 9, 3, 27. Now remember, the log base 3 of x is going to be the inverse. And that means we could just switch these. So my value is going to be 1, 0, 3, 1, 9, 2, and 27, 3. They are inverses of one another, so we can just switch the x and y's. So I'm going to do the exponential in blue and then the log in something else. So at 0 we're at 1, at 1 we're at 3, at 2 we're at 9, something like that, and at 3 we're really, really high, maybe like up here at 27. Okay, so this is my exponential. It's infinitely close to the x-axis, never touching it. And my log is going to be at 1, 0. So this is going to be, log is in green. 1, 0, 3, 1, 9, 2, 1, 2. And 27, we're at 3. So it's actually, and remember our asymptote is going to be x equals 0 this time, so it's going to be something like, oops. So it goes up very slowly, forever. Never touching that y-axis, even though it might look like it. So the domain of each, you guys can go ahead and fill in. Now consider this, log of base 3, which is going to be this, of -x plus 2 and then -1. We know the -1 is going to shift it down 1, but really with this negative, we have to factor it out. Just like we did with trig, we have to factor it out. Log base 3 of negative parentheses, actually x minus 2. And then -1, okay? Factor out that negative from both. So the negative means we're going to flip it. So it's going to look something like this. Instead of being at this point 1, 0, we're going to shift it to the left. We're going to shift it to the right too, which means my new asymptote is not going to be at on the y-axis. It's actually going to be on the right too. So this is my new asymptote. And I'm going to shift it down 1. I would try to plug in points into this to make sure that we get just a couple of critical points. So when I plugged in 1 in here, this is -1 plus 2 is 1. So actually 3 to the 0 power is 1. That's the only thing that's going to give us 1. So if you evaluate this, you're going to get 0, but then we're -1 on the outside. So it's going to be right there. And then also, if we plug in -1 into here, this is going to be 1 plus 2 is 3. 3 to the, only 3 to the first power will give it 3. And then we have -1, so this is going to be at 0. And so sorry, this is going to be at 0. And I know that this graph is going to look something like this. Okay. So you guys can check out the domain and range and tell me what you think. And you guys have one more set to graph on the next page. Have a great day.